We are live on the internets. Aaron, how are you, my friend?
I'm doing well, Sam. Yeah, thanks for having me on. It was good to meet you at Stir Trek the other week. That was fun.
Yeah,
Yeah, first time I've been out doing a tech conference in a while.
yeah. All right, so let's get started here. So, good morning, good afternoon, good evening, folks, wherever you're joining us from. Thank you for being here. Appreciate your time. This is the Pragmatic AI in .NET show. We do this every other Thursday. And there's a lot of hype. Our world is changing with AI, but we try to get to the realities of actually building and shipping stuff with AI. So I'm your host, Sam Basu, and with me I have Aaron. So before I start talking to Aaron here, let's take a look at the chat room. I know a lot of you watch this after, once we record this and post it, but a lot of you are also live with us. So I love to know where you all are, tuning in from. And looks like we got Jose Silva, if I'm saying your name right. Hello from Brazil. Actually, Aaron might not be too far off. Like you got direct flights to Brazil. He's in Houston, Texas.
Yeah, about 6 or 7 hours.
Yeah, there you go. Yeah. I'm in Northwest Pennsylvania. This is Uno Platform, our folks over from Toronto. Yeah, and you got some Akka.NET fans in here. Yeah,
My reputation precedes me.
yeah,
Yeah, there
it
you go.
does indeed, and it's a very, very good reputation. All right, so yeah, folks, please chime in wherever you're joining us from. So, Aaron, let's formally introduce yourself. Tell us who you are and what you do.
Sure. So my name is Aaron Stannard. I'm the founder and CEO of a company called PetaBridge. We are the commercial entity behind Akka.net. So if you've done any work with like distributed, or concurrent, or maybe real-time programming in .NET, you may have come across Akka.net before. That's been sort of what I've been working on. Akka.net kind of got spun out of a previous startup I had done in like the real-time analytics space. So that's sort of where my background is. And I've like everyone else in our software industry, I have been trying to squeeze as much blood from the stone of AI as I can in order to try to improve my personal productivity, automate away things I don't particularly enjoy doing. A good example, writing YAML files. I'm pretty happy to never see one ever again. And doing, basically just trying to, in some respects, trying to use AI to kind of expand my consciousness in a non-hippie way, but more like projecting my will onto a whole bunch of machines to carry tasks out for me. That's sort of what I mean by that. So yeah, I've had my skin in the game here for quite some time. And if you've followed me on Twitter or on a couple of other platforms like LinkedIn or on our Discord, you've probably seen me talking a bit about some of what we've been doing in the AI space. So
Yep,
Sam
that's
invited me on to share some of that with you, and I thought this would be this type of podcast where we're talking about like non grifter hype stuff and actually like what have you shipped is a
right.
really breath of fresh air, I think.
Yeah. So Aaron and his folks run PetaBridge. So if you need help with Akka.net, that's where you can find Aaron, and all the love there. So shared interest here. Aaron and me were at a conference together, and it was a few people who had a shared background with Windows Phone. So I did that for a few years.
Yep.
Good old times. And I love how nerdy you are, Aaron. So just before we went live, Aaron is geeking out about GPU chips and performance and all that. So let's get into it. So AI, you talked about it, Aaron. How is it changing how you build software?
So I'm one of those people that spends very little time in an IDE anymore. That's probably one of the biggest changes that's happened with me is that I don't, generally spend a lot of time like manually authoring code in JetBrains Writer is my tool of choice. I rarely use it these days. I'm largely using a terminal to do most of my
Mm,
programming now.
that's a
And I should
substantial shift.
it's a pretty significant change and to some extent not 100% positive all of that. I've one of the projects we're going to talk about on the call today is NetClaw, and I fired up JetBrains yesterday because I was convinced that the story Claude was telling me about how this certain bug got promulgated, it didn't add up, didn't align with basically my intuition and experience. And sure enough, I fire up Writer, look at the code myself, and I go, yeah, this is where that bug is coming from. And it's good to do that every so often, particularly on a code base where if you've had AI author most of it and you don't have that sort of like muscle memory on how it's interesting. Like when people talk about you can operate this higher level of abstraction where you don't need to worry about how it's made anymore. And I largely find that not to be true in practice. Now, like on an open source project like Akka.net, my livelihood depends on ensuring that every change we make to that open source project doesn't cause our customers who are like
Right.
Fortune 500 companies and big banks and manufacturers and energy producers and all that sort of stuff. Got to make sure that we don't rock the boat for them when we do a release. So one of the things that I think has positioned me very well to take advantage of AI is I read a lot more source code than the average software developer does, probably by a factor of 20. Yeah, I'm reviewing pull requests. I'm reviewing my employees' pull requests. I'm reviewing contributor pull requests. And also as part of our consulting, I am reviewing and our support stuff too. I'm reviewing code other people have written on top of our framework. So my ability to kind of mentally map what this like abstract piece of code I'm seeing on a web browser or in a terminal does without needing to step into a telesense or without needing to have an IDE in front of me has prepared me very well for reviewing AI contributed output.
Yeah.
That being said, the ultimate lie I think of a lot of shops that are trying to use AI to ramp up productivity now is that you're going to have a human review all of it. And I'm like, dude, at that rate, you might as well just have humans write it. Like
Right.
it's a totally insurmountable. If you want that velocity lift from having AI code, it means you're going to have to ship stuff people haven't reviewed with a fine tooth comb. And a second lie on that is that you were doing these code reviews before. Like I've seen what the bowels of, let's say, like, giant banks on Wall Street use for going and writing source code. And I guarantee you, not all that stuff ever got code reviewed. So the idea that we are going to apply this super high standard in an industry that still struggles with adopting basic things like automated testing, I mean, get over it.
Yeah.
It never works that way.
Yeah. But I mean, you have a lot of experience doing this, so you kind of see broadly where to look for things. So I'm going to post a link to an article that you wrote, which I found fascinating. This is Software 2.0. So you are essentially saying how the game is changing, and we have said this several times. Oh, and feel free to pull this up on your desktop. We can share your screen
I've
here
got
as well.
it right here.
Okay, so let's share your screen back up.
So you linked to the first article in the series. This is the second one, and I'm working on a third now.
So this is talking about, we say this in a lot of different ways, that code is cheap. It's just so much that you cannot even look at all of it with a fine, grain, comb. But what is still expensive is enterprise software and stitching things together. So what's your take with all of this?
So my take is that if you want to capture the yield from AI coding, you have to shift your strategy from basically being essentially a typist to being someone who thinks a little bit more like a risk manager, where your goal should be to de-risk the project at the front and at the back. So the front is your planning and specification phase, which is largely what this second article is a bit about. The more interesting and challenging problem is de-risking on the back, which is verification. The basic idea behind this is that if you think about this like a sort of a pipeline, you have this deterministic phase. Well, it depends on how much you use LLMs for it, but this deterministic phase of planning on the front end. And you're trying to essentially specify what it is you want to build. Most failures with LLM coding begin there. And the reason why is there's an adage that I've used as a manager of software engineers for many years, which is that your average software engineer would rather spend months coding in order to avoid hours planning. So software engineers are, and I say this as an open source author and as an employer, are profoundly terrible at reading documentation and probably 1,000 times worse at writing it. It is actually
Yeah.
comical how bad
Hmm.
people who are paid hundreds of thousands of dollars to do this job are at like reading the basic, like the most basic elements of it. It's probably one of the reasons why people are excited about LLMs doing this stuff, because now you can actually have
You
something
don't have
that
to
actually
read.
writes. You don't have to read, and it can write documentation for
Yeah.
you.
Yeah.
So
It's such a classic thing. Like to us, a lot of software developers, like this is ingrained. Like we think the real work is coding, so we just start on it as soon as we can.
yeah, and that's a that attitude will get you fired in the AI coding area. That code is king, and it's like, well, code has always largely been a detail, but there is an art form to it that you can
Hmm.
appreciate and enjoy, and it's also worth having standards and kind of knowing how to use code to like de-risk in the era of AI. I mean, I'll give you a real quick example. I ran into this last night when I was working late. We introduced a regression in NetClaw, which we have since fixed, where I'll talk a bit about NetClaw more later. This is basically OpenClaw written from scratch for .NET with an emphasis on security, simplicity, and reliability. The basic idea here. But we had a regression that I introduced. I found a bug where we were essentially spamming NetClaw works primarily through chat channels like Discord and Slack, and it has a what's called a fetcher we can use to, if you tag AI in the middle of a long thread, this fetcher allows it to go and read what was there before, so it gets caught up on the context. And that fetcher was running over and over again and essentially like billowing out the context window as a result of a bug that got introduced maybe a week ago or so. So I fixed that bug yesterday, but a new bug got introduced where we have some security primitives that basically define what audience is this chat room a part of. So chat rooms that are exposed to multiple people have a lower permission setting than audiences that are like a direct message to the operator. And so things like what tools you have access to change depending on what audience you're in. And what happened was we had left out the audience parameter when we fetched the initial message during a brand new session, which meant that if the agent tried to use tools right away, it failed. So, we caught this immediately and fixed it within like an hour of the bug being introduced. But the real problem here was we weren't using required properties or primary constructors to force the type system to always include this security context. So we had like this optional field on a record that got initialized to a default struct value, essentially. And that's sort of the example of like trying to build stronger verification systems, leverage the type system to do a lot of that work for you, where
Yeah.
the agent can't get it wrong because the type's shape won't allow it. And
Right.
this is
So.
a practice we've used for human programmers for years too.
So guardrails. So let me ask you this. Let me actually say, what my setup, my flow is, and then I would love to know what yours is. So if I'm building a client-side app, a native app, let's say, that I'm like you, all .NET. So my chosen stack is Uno platform. That's open source and it's cross-platform. So for me to put in the work up front and be able to validate, my flow is, there are a couple of ways in which you can spec things out. I like SpecKit. Sometimes it gets a little bit maybe too verbose, but it's there. Actually, hold on for 1 second. No, it's just a notification I had from the streaming system. Anyways, so what I'm trying to say is I will spec things out before I go. And then Uno platform, we have MCP servers. So I need AI to validate. That's in the part of my constitution, my guiding principles of working with an AI agent, that I need you to constantly ping the docs MCPs to make sure you're grounded, and then you need to validate the UI that you're building through MCP tools, interactive tools, kind of like Playwright for .NET. So that's my flow with Uno platform. So what type of apps are you building, and then what's your setup like?
This would be probably a good place to transition to like talking about TextForge, which is
Yes, please. Yeah.
a SaaS service I launched back in March. Ironically enough, I built TextForge I built like a self-hosted version of it that was just running on like one of our computers in our test lab to let me automate my sales work was what I used this for. 90% of my sales work is simply reminding people that they had agreed to do something and hadn't done it yet. whether that's
Right.
signing paying a bill, signing paperwork, whatever, so it's like, we're not exactly writing like the next great American novel here. This is all template driven stuff. But the problem with doing sales work is that it's much like it's basically an accounting process where you have all these different contacts that are in various stages. This is what you use a customer relationship management system to help you track. What I didn't like about our CRM that we use is that it has AI integration, but it's like the dumbest possible integration. It's like having Chat GPT autocomplete an email for you, something I get for free in Gmail.
Yeah.
So I'm like, okay, well, that's not useful. Thanks. I basically built a system to allow me to connect Claude Code via MCP. If I take a look at our docs here, actually, no, I've got even better. I've got an MCP setup generator that works for like any MCP tool on here.
Oh,
And if I
that's cool.
go down here, generate config, I can basically go and add this to Claude Code. And what
Mhm.
this would do is essentially delegate access to my inbox to Claude or any other one of these setups up here. And it would allow me to delegate access to my inbox. And it would, most crucially, if Claude generates an email on my behalf, it goes into an approval queue where it's kind of like a pull request. It's sitting there in an undeployed state, so I can review it
Mhm.
first and kick it back to the LLM if there's a problem. So this whole process is this whole application is built on top of Blazor server, Akka.net, and a couple of other ASP.NET components like we have an HTTP API. So that's all built with minimal web APIs. And then we use the official model context protocol plugin from Microsoft as well. And this application was 100% like coded via LLMs. Like I did a little bit of manual work designing the original sync system. But as I kind of outline in the Software 2.0 post, I kind of talk about how we used AI to construct it here. I basically had AI code the 99% of what was in here. And if you're thinking to yourself, well, how do you know it's high quality? It's like, well, one of the things we had to do in order to become basically verified by Google, we actually had to pass a CASA 2 security audit with their auditors. And that's no joke. That's a pretty serious process. And we were able to do that. I doubt most of the people on the .NET subreddit could pass that audit with code they wrote by hand. So
Right.
we're dealing with a pretty high bar as far as quality goes. And my setup for doing this is very similar to what I have in NetClaws, which is right here.
And I have so many questions about NetClaw, by the way. I'm sure we'll get to it, but
Absolutely.
let's talk through your setup.
So in NetClaw, the first thing we do is, so I have a skill. So I've got like a little repository of personal skills just for me and my team. And
Yep.
one of them is what we call our agentic bootstrap. And the idea is we have a little formula in, I don't know. Oh, okay. It's because it's a symlink. That's why. I'm going to go to agents.md. All right. So basically, we have a constitution that is specific to this project in here. So NetClaw's constitution looks different from TextForge's, and that also looks different from Akka.net because what those projects do is inherently not the same, right?
Right.
But basically, we kind of lay out like our current product direction. We talk a bit about the authority and scope. We have other related files that we encourage the system to read. You mentioned a spec kit earlier. We use another specification-driven development framework called OpenSpec.
Oh, right, yeah.
So we use that. I did not use that for doing TextForge, and I adopted OpenSpec after TextForge because I found keeping track of revisions when we were kind of refining how things worked in the system was really hard without having something that was a bit more well-structured. So with NetClaw, from day one, we've been using OpenSpec, and it adds a whole bunch. If I take a look through here, I think we probably have, 20 or so specs in here. Adds a whole bunch of files to your repository, but they're just marked down. So the cost is pretty minimal.
Right. Easy to maintain. And it's, more detailed for the agent to read because they love the structure.
They do love that structure, and having those commands for being able to validate, like, does this conform with the spec is actually super useful. So that's one of the reasons why we ended up picking that. But we have this idea of task routing where I can have different agent personas. Now, NetClaw is just pretty simple, so I think it only has two. One's for planning and the one's for actual execution. But in a system like TextForge, I have different personas for UI, for doing marketing when I'm doing things like SEOing a page on TextForge. And then I've got the actual backend engineering personas on there, where there might be different little markdown files that have like an addendum for what that specific persona is supposed to do. NetClaw is a pure backend system, so it doesn't really, and also it's an open source project, so it doesn't really need as much of that marketing pizzazz. So it's got a much simpler looking constitution. Then we outline a couple of discovery rules, talking about configuration sync, and then I've gradually built up this quality bar over time. Like, here's one of my favorite rules. I like using the value object pattern, and I've liked using this before AI, but it's one of these things that's gotten more valuable with AI, which is, in order to avoid primitive confusion, go ahead and wrap your GUIDs, your strings, your ints in a read-only struct, and basically use that to kind of declare that type on here. Well, one of the things AI will very helpfully try to do is add an implicit conversion between that value object and the actual primitive data type that's in there, which completely negates all the value of actually having the value object. So we have a rule on here. It's like, nope, you got to either explicitly cast or you've got to new up the value object. And these are just little things we kind of gradually add to here. Like I just added this the other day that, we're not a Java project. We don't do one file per type, so stuff like that.
Yeah. No, and this is good to also point out what you're saying. Like this is not built like from the scratch. Like you can iteratively add to this. Like this is your constitution.
Oh, this is where we get into the really slick stuff. So project context, and basically just kind of talks a bit about some of the different technical pieces, release notes tooling. I don't think I have my implementation plan file in here anymore. I think we got rid of it. But if I take a look at our skills, let me see if I can find Claude skills. There we go. Binary swap. Where's my, here we go. All right, let me pull this one up. And this one.
Oh, I'm reading Ralph loops in here.
Yeah. And then we have a, now Claude just yesterday completely nerfed the ability for this to work.
I heard they had some issues yesterday.
Yeah. Well, so I have an open code version of Ralph too. So screw you, Anthropic. so I can use this with Copilot or Codex if I want to, or my self-hosted models. The basic idea is, and you know what? Let me pull up on a different, I'm just going to do this off screen real quick. I'm going to grab TextForge's repository, which uses the exact same scripts, but it has a real implementation plan. Here we go. Okay. Let me go ahead and pull this over. All right. The idea behind, so this is what I'm going to talk about in the next Software 2.0 series, is doing unattended coding, where you basically can go ahead and kick off a long running operation. Like some of these, I've had some of these run for like 12 to 24 hours before. And usually it's doing things like taking a bunch of UI mockups and turning them into real Blazor server pages. And it has to run a lot of interactivity tests with Playwright to make sure everything's wired up correctly. So it has a complete specification to work from, and it has complete validation requirements on what needs to happen. So if I scroll down here, this is all I think, our issue backlog and other stuff. The way the Ralph loop kind of works, let's see.
So while you're pulling this up, like just for the audience, in case somebody has not used it, and I actually also have not used Ralph all that much. What it is, if you have a single prompt, one-shot way of asking the agent to do something, they will try, and then they will eventually come back and say, I'm done. But, who's to say that you're actually done? So this is the validation loop to say, here are your exit conditions. Don't come out of it until you are meeting all of those, successful criterias.
Yeah, exactly. And basically the idea behind this is, so I don't have a great example of like a big epic to implement right now, because we're just not really doing that on any of these projects. We're kind of doing more targeted bug fixing. But when we were building out TextForge originally, we probably did 6 or 7 big Ralph loops to go and implement stuff. And the way it works is you would specify, and this is what OpenSpec can kind of do a little bit more, sort of, I guess, robustly is not the right word, but it's more consistently is how it can do that. where we have something like, okay, we need to add thread sync to our set of LLM permissions when we create API tokens. All right. And here's the GitHub issue this corresponds with. And here's basically the area we're working on. And then you see this down here, verification, level 1, tests that need to be covered. And here's the criteria for when this is done. What the Ralph loop will do is kick off and if you take a look through all these backlog issues down here, what the Ralph loop is going to do is it's going to use one context window per task. So it basically kicks off one context window. There's already a product requirements document and an implementation specification that kind of outlines what it should do. So there's no need for a planning phase. You kind of do that in bulk up front. What there's a lot of is verification. And so we have different verification levels. Level 1's the cheapest. Down here, level 3 is the most expensive. This means a UI smoke test. It means that an agent has to actually produce screenshots of it successfully achieving a goal inside the verification loop here. And here's the part that gets really cool. And this is the actual, you can pull this off the NetClaw repo. This is the actual Ralph loop that runs that. But here's where things get pretty interesting. The Ralph loop skill down here that gets invoked when it starts outlines, here's where you should be recording. For every single step, you need to record a log of what you did and why you did it. So essentially, this is like observability into the agent's reasoning. There's also an artifacts directory that gets created for each run where you need to go ahead and store things like screenshots if you're using Playwright. What we have every so often, if I scroll down here, yeah, these are all verification. There's verification steps, screenshot persistence rules, blah, blah, blah.
So really cool. I was going to say, like, this is exactly where you're putting in the work up front, to your point earlier. Yeah.
Here's the cool part is that this process is actually self-improving. And the trick to this is we have a checkpoint that runs and it's configurable depending on what parameters you put into the script called adversarial review, where every n iterations. So if I'm doing like a 27 iteration Ralph loop, I might have this run every 3 iterations, where it's going to kick off a kind of a bulkier looking process where it's going to review all the work that was done between the last review and this one. And it'll actually rearrange the implementation plan depending on what bugs it finds. And it's going to go ahead and basically look through the structure here. It's going to look at what the verification criteria were for each step. And the really cool part, I don't know where it says this on here. Yeah, hard fail criteria. It can actually go and update the claw.md files and the constitution depending on what it finds. So good example, if an agent repeatedly fails to take screenshots when it's doing level 3 verification, it'll try strengthening that language either in the skill that's being used or in the claw.md file or one of the other files on here. So it's going to try to harden up the process a bit. And this is where you can kind of get some really interesting amplification of quality inside the system. And this generally works pretty robustly, all of it, behind the scenes. Now, the reason why it works robustly is every setup for a Ralph loop probably takes me 3 or 4 days of planning to get that ready to go. It's not basically computer build me $1 million SaaS. You know? It's much more detail oriented than that. I have to do things like approve pixel perfect UI mockups and be as exacting as possible. And I'm spending a lot of time manually iterating on all that before I have it go. So I'm essentially acting more like a product manager than a software developer to some extent here, where I'm trying to get the UX right. I'll go ahead and lay down some requirements that are technical too. Like I'll say, we're going to stick to Blazor server. Do not include any extraneous third-party JavaScript packages other than like this small list, and don't include any commercial UI component frameworks and blah blah blah. Like I'll go ahead and maybe lay all that out like as sort of we're in a requirements document somewhere, and that gives it some pretty good guardrails. And the agents will still make mistakes periodically, but having this adversarial review stage where it'll find bug fixes and reorder the list to have those get implemented first. And at the very end, it might produce a backlog of like, here's some minor issues, like this div was not styled properly. It'll produce some minor issues like that you can do another cleanup pass on later. And the trick to all this is that this is extremely systematic. It's not YOLO prompting. This is kind of thinking more of like an agentic system.
Yeah.
The,
Yeah, no, I
yeah,
mean, and then this is like we have said this multiple times. This is not YOLO. This is not one shot, build me a thing. This is, putting in the work over days and days to
yeah.
get the loops exactly right. Can I pivot one time and just, or I mean, were you going to talk more through this? Because I had a question from something you said before.
Go ahead.
So you talked about TextForge and what it does, and I'm talking about governance and quality controlling AI agents, because sometimes even with the right guardrails, they do their own thing.
Oh yeah.
Case in point is something that you have shared. This is the OpenClaw email things. Yes, inboxes are frustrating to deal with, but
Yeah.
sometimes, I mean, it's your relationships that matter sometimes at the end of the day. So what's your thought on forcing agents to stick to the guardrails?
So basically, you have this sort of in distributed systems, the term that I've heard, other developers use and we've used ourselves is this concept of what's called bulkheading, where we're stealing that term directly from the shipbuilding industry, which is where you don't want to have just one thin sheet of metal protecting your ship from the water and the ocean, because if that sheet of metal gets penetrated, you're the Titanic, and that's
Mm-hmm.
and the end, right? So the idea behind bulkheads is you want to have sort of a safety layer where if one bulkhead gets penetrated, that should not completely compromise the vessel, and it allows the ship to remain resilient against a pretty fatal failure mode there. In distributed systems, we kind of think of this like one failure on the network, which is an inevitability, should not completely compromise the application where we have to take it offline and rewire all the state and do it manually again. The idea behind this with AI is deterministic bulkheading, where agents are non-deterministic. And the best way of explaining that is the same agent given the same prompt 3 times will produce 3 slightly different variants of the same work. And that's because there's an inherent randomness to how agents make decisions. And it's work that agents produce is non-reproducible to some
Yeah,
extent.
and then
And that,
there's
yeah.
beauty in that creativity, which is what we prefer at times. But you're talking about building multiple layers of safety.
Yes, multiple layers of safety. Telling an agent in a prompt, "Don't do this," is like a paper thin way of trying to basically protect yourself from the agent going wrong. Like basically the whole idea behind TextForge is basically that if I go and pull up Slack here, if I pull up oh, here we go. Here's a good example. This is NetClaw running here. And what I'm having NetClaw do in this exact session right now is I have a skills server that basically maintains a feed of agent skills. And actually, funnily enough, NetClaw is the consumer of those. It is asking me for permission to create a new directory inside this repository on the virtual machine that NetClaw is running on here. This is a good example of a deterministic boundary where the agent's going to go ahead and cruise and do its stuff. And if I scroll up through the history here, the agent's been able to do a ton of research and web fetching and reading markdown documents, doesn't have to ask for permission to do any of that. And the reason why, those are what we call reversible operations. An agent reading
Mm-hmm.
a file and is pretty, for the most part, pretty harmless. There might be some exceptions to that, like if the file contained a secret or whatever, which is a bit of a sandboxing issue. But down here, I have things like I approved the agent's ability to go and sync our master branch on my fork of this internal repository we have. And now it's asking for the ability to start mutating this project, creating directories. So I can say down here, you know what, this repository, it is generally pretty safe for you to create directories in here. It's something we have to do to work with skills. I don't think I've had NetClaw actually edit this repo before. So I'm going to go ahead and basically give it permission to always edit directories only in this, basically in this folder, more or
Like
less.
you're containerizing it a little bit. It's like only in
It's
this.
it's compartmentalizing it, and this is very similar to the approval system you'd see in Claude Code if you were running it without, with this normal permissions, more or less. One of the subtle differences, though, for something like NetClaw that runs in the background, is that this agent is doing stuff without a human sitting there. So I usually run quad in full blown YOLO mode when I'm sitting, because I'm sitting down in front of it and watching what it's doing usually. If I've got NetClaw doing things like, trying to push the repos behind the scenes or editing my Notion documents or sending emails, I want to get an approval when it's going to do something potentially irreversible, because that's one of those deterministic boundaries where it's like, nah, I should probably go and review that. And this takes 2 seconds to review, and it's happening. And I'm not sitting here like NetClaw is not blocking me in my daily work. This is like bonus stuff it's doing for me in the background. My daily work, right now I'm talking on this podcast. I might be doing an Akka.net training shortly afterwards. And then when I get down to doing, some administrative or ops work, or doing some sales work or whatever, if I have NetClaw running around cleaning up GitHub issues, or trying to generate some marketing assets for me and that sort of stuff, I don't really care very much about what it's doing up until it's about to post on my Twitter feed, or it's about to push to my repository, or it's about to write something to Notion. Those are the stages where it's like, yeah, probably be good for me to eyeball that,
Yeah.
It's like this is one guardrail. And then if I take a look at TextForge's features, I think we have a screenshot of this here. Well, we got a YouTube video, which I won't play. But if you take a look at, if I go to the docs, if I see how drafts work, let's see. I guess we have a screenshot of the webhook notification you get in Slack. I think we do. Maybe not. Basically, I get a notification in Slack when there's a draft ready to be sent, and there's a big fat approve, reject, or view button on there. And AI agents, get a lot of stuff wrong when they're composing emails. Claude kind of sounds like a jerk a lot of the times. Like it sounds like it's threatening to break our customers' kneecaps if they don't pay their money. And it's like, all right, guys, we're not an organized crime. We can cool off a little bit. So I basically will go back and refine drafts and edits quite a bit when I'm doing that. I have some skills in place to kind of parameterize and templatize the emails that it sends. But even with those guardrails, like templates and skills and guidance, the agent, even one using like Claude Opus 4.7 or whatever, will come up with some pretty wild stuff. It'll send it an email sometimes. So you can't let it be completely unsupervised. So you got to basically pick, where do we need to put that bulkhead in place? And in my sort of heuristic for determining that is anything that is irreversible. That's where you need a bulkhead. And then the other thing I'd mention is like using determinism as a quality control on things like source code. So unit tests are like the weakest and crappiest form of like deterministic control, because agents can just vomit those out. Those tests are often very anemic and don't do much. Integration tests are like a major step up in quality from there. But I also do things like write verification programs to basically go and check the output. Give you a really simple example of that. If I go to my personal LinkedIn, or not LinkedIn, GitHub here, if I look for link validator. So for all of our like static websites, and also for TextForge, I basically run this link validator. This is like a brute force system for validating that every link and every image resolves. So if I'm having AI do things like move documentation around or change endpoints, I have this run on the live running website. And if there's a problem with it, and by the way, this also validates external links that we link to as well. So like one of the biggest use cases for this is in our TextForge documentation, we have links to all of the model context protocol configuration pages for every third-party tool that might want to use us. Dude, we have no control if they move that stuff around or whatever. So if they do that as part of our build pipeline, we go and recheck all of those. And if we get a 404 back, the agent's going to get that feedback and it's going to have to go and fix it, So you want to basically make sure there's something that the agent can't cheat and get through on there. So that's one example.
Well said. Well said. Now, you mentioned this a few times, but I'm going to pull up NetClaw. Tell me about this, because OpenClaw has maybe scared some people in terms of just how much it can do, and again, where those guardrails and those bulkheads are. So what is NetClaw? What does it do for you?
So NetClaw this is actually the first time I've talked about it. I've teased it on my Twitter thread when I was still doing development on it, and I just open sourced it maybe a week ago, and I still have not publicly told anyone this repository exists yet. People have just been kind of finding it via my GitHub activity. And the reason why I haven't really talked about it publicly is there's been some really annoying user experience issues that I wanted to get fixed first. The release I just pushed this morning addresses those.
Look at that. Hot off the
name
press.
Yeah, hot off the presses. Namely, the problem was our approval system was asking for permission way too frequently, like to a point where it was like, okay, this is obnoxious. So if you basically subject people to prompt fatigue like that, they're going to turn the permission system off, and it becomes self-defeating at that standpoint, right? So that's it's a user experience issue that can become a security issue if you don't get it right. So it's that was like less of an engineering problem and more of like taste making is how I describe that. So here's what NetClaw is. I tried using OpenClaw when it first came out because I have a bunch of use cases for it that are not engineering. Like I'm pretty happy with my open code Claude code setup, but like you know what I'm not happy with? Having to remember to go and check like Google Webmaster and Google Analytics and do all this like essentially data analysis for our marketing. I've also got other things like scheduled reminders for like, oh, we got to file our sales taxes this quarter. Oh, we've got to go and check to make sure that all of our support tickets are handled with an SLA. And I have just this like magnitude of all these scheduled things that have to happen. And then I also have that in my personal life. I've got 3 kids under the age of 5, you know?
Oh,
So
wow.
I've got lots of stuff going on there. Oh, we got to have someone come inspect the roof. Oh, we've got to, it's just like there's just a lot of organization everywhere that really accumulates and becomes kind of this like cognitive debt.
Mm-hmm.
I built NetClaw to do 3 things really reliably. First, I tried using OpenClaw and found it to be very bloated, generally speaking, pretty unreliable when I first started using it. Like a good example, if I had 2 parallel Slack threads, they would both blend into the same context. So as an end user, I didn't have an easy way of having 2 parallel conversations with my agent, which I found to be kind of frustrating. And then the real kicker for me was that OpenClaw would not work with models that were smaller than 400 billion parameters. In fact, it would really scream loudly about that, which for me meant that it completely ruled out using local inference models. Unless you're running, a fairly expensive inference setup, you're kind of out of luck with if you need 400 billion parameters. So I redesigned NetClaw from the bottom up to, I think OpenClaw was inspirational, had a bunch of really good ideas. Hermes Agent was something that kind of got released and was developed while I was already working on NetClaw. And I think that's probably an improvement, but they have fallen into the same trap OpenClaw has, where like, I take a look at we merged in 1,000 pull requests last week. And as a much more experienced open source author, I'm like, that is absolutely terrifying and not a good sign at all. Like, you should not be merging in 1,000 pull requests. That means everyone's asleep at the wheel, effectively. I merged in 40 on OpenClaw over the course of probably the past 4 days. And that's because I was furiously knocking out bug lists over and over and over again. And I could do some of that in parallel, but these are things like very acute targeted fixes to solve a reproducible problem that we can identify in our code base. So NetClaw's philosophy is to basically be lean, work really well with small models. I originally tested it with Qwen 3.5 9 billion, which I can run on a GPU that is 6 or 7 years old pretty reliably. So it's a pretty good model. It's also multimodal, supports long context windows. Multimodal meaning you can send images to it. One of my favorite things to do is take screenshots of stuff in Slack and fire it over to NetClaw and say, hey, can you do X with this? Most of the time it's trying to deal with like UX issues that I find on our websites, but sometimes it's for something as simple as I took my kids out to on a road trip. We saw a snake down by the river, and I took a photo of it, and I asked NetClaw, what type of snake is this, and is it venomous? And got back to me with like basic information that was as good as what ChatGPT's research model could do. So pretty slick. So I built it to be reliable, scaled down with small agents. I built it to be self-hosted. I built it to be simple, where we don't ship with a UI or anything currently. It's all meant to be basically run through your chat systems. And right now we support Discord and Slack. One of the things I'm hoping we'll do as we if we get some interest from the open source community is expand it to things like Microsoft Teams or WhatsApp. I'm working on a Mattermost plugin, which is what I want to use for our home lab inside my house. That's currently not passing at the moment. I'm probably going to need to redo that. But basically, the idea is like multiple chat systems, multiple providers. If I go and fire up, let's see.
Yeah, this is very cool. I just wanted to, commend you on one quick thing. Speaking of, NetClaw being working behind the scenes, but from the UI UX standpoint, you have a beautiful website, by the way.
Oh yeah, I should pull that up.
Yeah, and how is this made?
This is using Astro. I'm not sure what theme it is. This is, by the way, the private version of it that I've got hosted. This is, by the way, another detail. I work on a virtual machine with SSH and tmux. I use Tailscale to secure it. This is Tailscale serve, so it's generating a secure temporary URL that's forwarding from my host computer here to my virtual machine. And what I'm trying to do is get this diagram of how our memory model works fixed, because the ASCII2 is not lining up correctly right now. So I'm working on fixing that. But yeah, this is all built.
Well done on the website. Yeah, what you have out there looks nice.
Yeah, this is all built on. Whoops, linked to the wrong page there. But yeah, this is all built on Astro.
Yes.
And yeah, NetClaw is available for install. We basically maintain a release feed here, and we also have Docker images. And if you don't want to use our release feed, you can download the binaries directly from any of our GitHub releases as well. We do cryptographic signing on the production release feed, which is just hosted on Cloudflare to basically validate that the binary you're getting is the binary we're advertising. And we also distribute NetClaw as a Docker container as well down here.
Nice. Yeah.
The other thing that I've done to kind of help manage NetClaw. So NetClaw is pretty cheap. I'm running it right now. If I go and pull up, if I do NetClaw status right here.
Oh, this is like behind the scenes look at how things are running.
Yeah, so I'm running Quen 3.6 27B, which is the UD here. I think this is the Unsloth model. So I'm running this, and I have Slack connected. I've got a couple of different MCP servers on here. So one of the things we had to do to make this work with small models is be very careful about tool discovery. Cursor, I think, was the first to really pioneer this approach called dynamic tool discovery, which is basically that the active set of tools that are loaded into context at any given time is finite. So you can go and plug hundreds of MCP servers if you wanted to in your application. And what happens with NetClaw's context window is it produces an index of like, here's every tool you have access to. And it's just a static like file basically that we produce. But the actual tool descriptions and metadata aren't available until you call a loader tool. That basically loads that into memory. And so I've had NetClaw behind the scenes connecting to Notion, Memorizer. Memorizer is another MCP server we built here at PetaBridge. It's basically Notion for agents. So like a little wiki they can manage. And then I've had it use TextForge, and I've had it use Playwright behind the scenes to go and do all sorts of stuff for me.
Nice. So you're saying like if you have a huge number of MCP tools, all of their metadata essentially takes up memory and context, window space.
It takes up context, but using the dynamic tool loading, you only have that context occupied by tools that have been called within the past couple of turns, essentially.
Sure.
So this helps kind of keep that compressed.
Yeah. One big question. I'm also going to watch the time because I know you said you have training coming up at the top of the hour. You said OpenClaw and other things used these huge public models while you are pivoting towards using local small ones. So what's your experience like in running models locally? What are you running and what type of hardware? I know you're a geek, but yeah, there you go. Show us the stuff.
So I've got 5 computers, maybe 4 that are all running GPUs inside our test lab. 2 of them are just old gaming rigs that I like kind of revived and turned into inference servers. So this is one of those gaming rigs. I swapped out the old NVIDIA card that it used to have, and I put in two of these brand new AMD Radeon Pro 9700s. If you're trying to get a lot of VRAM, this is the absolute best deal in town. These cards are like 13 or 1400 bucks a pop, give you 32 gigs of VRAM, as you can see on the chart right here. So I'm running a full instance of that Quen 27B model on each one of these cards currently. So there's no tensor parallelism at all, no sharing. Then I have a reverse proxy that load balances between them. NetClaw emits a session ID header, and I just have a caddy instance that basically does hash-based routing on that header to make sure that all sessions for all requests for the same session always get routed to the same GPU. So I am able to reuse the KV cache that way. So I've got that set up here. This is working pretty well. The one downside with the AMD cards is that the inference stack is way less mature than NVIDIA, so you're not going to get comparable performance just yet. That being said, AMD's realized that they're leaving like hundreds of billions of dollars on the table by not having CUDA. So they are working very quickly on their ROCm stack, which is basically their kind of programming equivalent. And it's catching up. There's a lot of engineering work on it. Lots of people are kind of identifying these AMD cards as a great deal compared to the NVIDIA ones. So this is what I've been using to run NetClaw basically since I started developing it, is these two cards here. Looks like, yeah, so you can see here the power keeps spiking up. So this card is active. This one's idle right now. It just doesn't have anything to do. I actually have no idea what's even running behind the scenes because I fired up NetClaw at the start of this session. So whatever it's been doing, it's spent an hour doing it. Fine by me. That's kind of the idea. And then my new toys I just bought. I bought a pair of DGX Sparks. These are NVIDIA's little supercomputers for doing unified memory access. And so in this case, this machine has 128 gigs of unified memory that can be used both for the RAM of the computer and VRAM for you actually running models. So this machine is running another one of those Quen 3.6 models. I've got one that's running the mixture of experts model and another one that's running the dense 27 billion parameter model on here. But you can see this thing's using 104 gigs of RAM. So it's using VLLM, and it's basically got a pre-allocated cache, and it's pretty bulky. These DGX Spark machines get a little bit of criticism because their memory bandwidth is somewhat slow. It's like 270 gigs per second. I was able to get really fast token speeds using some mixture of experts models on here. So I used Quen 3 Coder vNext. I yanked that model because it was like a dog off a leash when it came time to do coding. Just like I didn't feel comfortable basically letting it run hog wild there. So I yanked that. I also had a version of Quen 3.6 27B that was using speculative decoding and a type of quantization that goes a lot faster. Yanked that because the speculative decoding was causing like tool calls and thinking to fail. Like for instance, it generated a text forge email to a customer that had absolute gibberish in it. Like it looked like it was talking to itself. And I was like, okay,
good thing you're validating those emails going out, right?
Yeah, like I said, you got to read it.
Yeah.
Well, the first thing that jumped out at me was the formatting of that email made zero sense. Like it was like kids' crayon drawing basically in terms of how it had rendered it. And then the actual content of what it wrote to the customer was pretty horrifying. So I pulled the plug on that. Working on adding some new models now. There's a couple of great websites for trying to basically get yield on the DGX Spark. There's like sparkarena.com and a few others. So I'm trying some of the recipes they recommend. This was these machines are fairly expensive. They're like $4,500 a piece. So it was a pretty big investment for us, but it gives us an opportunity to run certain types of large self-hosted models locally, because I can cluster one model across both of these machines. So if I wanted to run something like a GLM model or DeepSeek for Flash or one of those, I could theoretically do that. Problem is with some of those models right now, I'd get like 2 tokens per second, which is unusable. Anything below 20 tokens per second is pretty rough, So that's why the mixture of experts models tend to work a lot better on these Sparks. So there's a lot of let's say wild west stuff going on with self-hosted inference. I'm betting on self-hosted inference simply because I think that and we can already see this with Copilot and Anthropic. People are going to jack up the price
It's
on
coming.
cloud-hosted inference, and I feel like I'm thinking as a CEO, not as a software engineer, right? I'm thinking like, dude, I would much rather have a big capex allocation where I go and buy hardware and figure out how to maximize yield on that than have this completely uncontrolled pricing that changes every week with a provider like Anthropic. That's just like not a good.
Because
That's
it's
that's a.
not in your control, right?
It's not a tolerable risk for me. Yeah, you want to hedge, and so
Right.
self-hosted inference is a great hedge.
Yeah. All right, Aaron, this was a whirlwind tour. This is the last bit. This is hardcore stuff because I don't know how many people are actually looking into this. But this, by the way, I posted like that's the NVIDIA DGX Spark that Aaron is talking about. So yeah, not cheap, but yeah, go ahead.
If you're in the US, the best place to get a DGX Spark is your local micro center. If you have one, they carry these.
Yeah.
That's what I'd recommend doing. They actually are starting to sell a 2-pack of these that come with the RDMA cable that's built into there. So
the original home of the nerds, micro centers.
Yep.
All right. So this was amazing. So Aaron, where can people find you? This is you on Twitter or X, but PetaBridge. That's your organization.
You can find me on Twitter. I'm usually pretty active on there. The other place to go ahead and locate us, if I go to the NetClaw Dev organization, we have a Discord available here. It's a little under-featured at the moment. I haven't done the normal pizzazz, dressing it up and adding rules and all that. That's a good place to get a hold of me if you want to give NetClaw a try. And the other place, of course, you can find me where I am always active is if you go to the Akka.net Discord, we've got like 1,100 people in there. That'd be another good place to find me too. So those are the three areas. I don't check LinkedIn very often, but I do check those other three.
Awesome. And again, that's the netclaw.dev. I'm pointing out the URL here. Congratulations on getting that out of the door. And TextFort sounds amazing as well. So you are really at the front lines here, pushing the envelope. So Godspeed, my man. Keep pushing.
Thanks for having me. And if people have questions about NetClaw, I'd be happy to answer. Thank you very much.
Absolutely. And congratulations on shipping all the things. Like here's an example, people, of, somebody really hardcore shipping real things with AI. So Aaron, I cannot thank you enough for taking the time of your day to come and chat and also showing us behind the scenes look at your setup. So this is amazing.
Thank you.
All right, so folks, anyone watching online, we actually have quite a few folks, so I feel bad, but we got to be watchful of Aaron's time here as well. But catch the recording; we'll put this up on YouTube's. But thank you so much for tuning in. If you're watching this live, thank you if you're watching this later on. But again, huge thank you to Aaron. This is the Pragmatic AI Show, and we'll be back on in 2 weeks, another Thursday. 11 p.m. or 11 a.m. Eastern is where we go. So join us back then. Until then, stay productive. I'm going to bring down your screen here, Aaron. And stay well, stay productive. Use AI the way you want to be productive. And take care. All right, folks, that's it. And bye.